Welcome to my project video for Mastaba. Now, Mastaba is a 3D escape room game created using the Unity engine. You play as a modern-day Tomb Raider who finds themselves trapped after the entrance closes behind you. To escape with your life, you must solve a series of puzzles left by the Egyptian god of mischief to reveal the secret exit. There is currently very few 3D escape room games available, with none of them being themed around ancient Egypt specifically, so I thought that this was an area to be filled in the market. I sought to create a game that would not only challenge players' critical thinking skills, but also immerse them in an atmosphere of mystery and adventure. Now here are some of my key aims. I wanted to create an immersive environment for the game to take place. I wanted to create a range of mental and physical challenges for the player to solve. I wanted to allow players to interact directly with their environment via an interaction system. And I wanted to structure the room in a way that allowed for linear problem solving and kept the player moving forward. Now, at the time of this demo, I've achieved most of the aims and requirements that I outlined in the project proposal, as can be seen here. The majority of them are already implemented. There are 3 that are scheduled for the final build, and there is 1 that is partially completed. And like I say here, I have some small additions and refinements to make before publishing the final version. The character set will be created to provide hints and keep track of time. Graphics will be overhauled, and custom sprites and models will be made where I can with the time that I have. And the room design will be optimized, things moved around for aesthetic design. And settings will be added to allow non-developer customization. I believe these additions will only require a small time frame to complete, and I've already scheduled this. And that's it for the presentation. We'll now start looking at the game. In this next segment, I will show a development build of the game to display some of the features and the code behind it. As you can see, the game starts with a standard loading screen. There is start and exit buttons, and there will eventually be a settings button that will allow the user to change things like sensitivity. Now if we click start, we can load into the main game scene. Now, there are many systems that I implemented into this game. The first one we can see immediately. There is a hotbar system with 7 icon slots. Items can be dragged into these slots and equipped to be able to be used. There is also a toggleable inventory system, which allows items to be moved around and added to the hotbar. As you can see, the inventory system is a singleton. This means it has an instance which is initiated when it awakes. There is then multiple methods that allow this system to be managed. Items can be added to the inventory can be closed, opened, you can check if it is full, you can find the next empty slot to add an item to, and then there is a general update, which lets you open the inventory by using the E key. The player also has a head flashlight, which they can trigger using the F key. This can allow them to examine things in more detail. This flashlight is attached to the character in the hierarchy view, and the script for this is also very straightforward. It gets the light component from the flashlight, and then triggers this when the F key is pressed down, and untriggers this when it's pressed again. Next, we will take a look at the interaction system. As you can see, there is a crosshair in the middle of the screen. When you approach an object that is interactable, it will change into a hand symbol, and it will also display some information on what you can do with this object. For example, with this chest, you know that there's a number lock. Or with this cat figure, you can rotate it. Like the inventory system, the selection manager is also a singleton instance. It uses a raycast to hit objects that have the interactable script attached to them, and depending on the tags of these objects will then determine what to do with them. Then we have our chest lock system. The first one you can see is a number lock. It allows you to scroll through numbers 0 to 9 and to enter a code. If we enter the code correctly into this lock, the chest will open, allowing us to gain whatever is inside. In this case, it is a clue. This clue can then be dragged into the inventory and attached to the character for examination. So as you can see, this is an eagle symbol, which will relate to a later puzzle. There are also more kinds of locks. This requires a key, from which the key is hidden inside of this vase. As with the note, this key can be added into the hotbar and can then be used to open the chest. This then reveals more clues. The chest lock system script handles the UI that is involved in interacting with a chest.
It opens and closes the UI, and it also defines the methods for the buttons to use in order to increase and decrease values correspondingly, and it has different options for this between letters and numbers. It also lets the code be checked, and it also triggers the animation to unlock the chest.
More than one room in this game, however, but you can only get there via a hidden corridor. To unlock this, you must rotate the cats to face the corresponding colours on the wall. And here is a pressure plate riddle. There are symbols corresponding to the pressure plates, which as you can see, also correspond to symbols you got on the clues. You can then use the code to hit down these pressure plates, which will unlock the final room.
Of the management scripts, this is another singleton instance, which allows it to be referred to by other scripts easier. This has an update method that keeps track of how many plates are currently stepped on. If all of the correct plates are stepped on, it will then unlock the door. However, if more than 4 plates are stepped on, it will reset them. This means that the player cannot do trial and error to figure out this puzzle, as it would take too long, and they must get the clues from the chests to be able to figure this one out.
As you can see, the final room is similar to the first one, yet there are some different puzzles. Firstly, there are symbols on the walls. The number of these symbols corresponds to a code, but you don't know which order until you unlock another one of the chests. Over here is a Sphinx riddle. There was also one of these in the first room that we didn't look at. The Sphinx will tell you a riddle, and you will solve the answer and use it to unlock a letter lock. Now letter locks have a choice between 10 different letters that you can escalate rather than the entire alphabet, which makes it less time consuming. This will unlock another clue.
Any object that is interactable like the Sphinx will have this interactable object script. It can handle lots of different types of operations by comparing the tag of the object. It does this whenever an object is left-clicked upon, whenever the player is in range. For text-based things, like the Pharaoh and the Sphinx, it will then output the corresponding message depending on which item was clicked. Or for things like the key or the clue that can be picked up, it will then add them to the inventory.
This clue is where letters have been replaced by numbers, and you can use this to get the final clue. The final clue states that one of the pharaohs lies, but the others tell the truth. And in this puzzle, you can interact with the pharaohs, and each of them will tell you a statement. And once you figure out which of the pharaohs is lying, and you figure out what the code is, you can trigger a harp sequence. This unlocks the final door, and once you pass through, you'll reach the end of the game. Now this exit screen will have the time taken with the level just above the exit when this is completed. Thank you for watching this presentation.